Okay, so here we're going over graphs of functions, more specifically. I know we looked at graphs earlier. I just like the visual representation. Grab my pencil. Okay, so here the graph of the function f is shown to, the function f shown to answer parts A through N. So this is a really long problem. We're finding f of negative 21 and f of negative 9. So when we're doing this, that's where this f of x equals y comes in. So they're telling me right here when it says this f of negative 21, they have x equals negative 21, and they want to know what is y. So if x is negative 21, y is what? So let's see, when we have x is negative 21, y is negative 2. I really need a code word up here for this one. And then it's x is negative 9, what is y? What is y? So think of it like that. When you see this with an equal sign, they're saying x is this value, what is y? Because f of x equals y. So the x is negative 21 in the function, so the y value is negative 2. The x value is negative 9, so the y value is 3, because that's this one right here. So x is negative 9, y is 3. I guess another reminder for this set is going to be x then y. Okay, so 3. And I clicked off of it. I know this gets confusing for people. Okay, so now we have f of 18. This is x is 18. What is y? So when x is 18, y is positive 2. So we're going to have positive 2 here. And then it's x is 0. What is y? So when x is 0, right there is x is 0, because the first one's 0. Y is negative 1. So our answer is going to be 2 and negative 1 because these 2 points. And when you're looking at the graph, be sure, like, because when I looked at it first, I saw that negative 3, 0, because that's where x would be 0, but that is not the point that goes there. So be sure you look like x matches up. So I looked down and saw that's where x is 0. So when it's 18, it's 2, and when it's 0, it's negative 1. Okay. Is f of 6 positive or negative? So we go to where x equals 6, and now they're not asking for the specific value, they just want to know positive or negative. So when x is positive 6, this is negative, so that would be negative. Okay. Is f of negative 9 negative or positive? So when x equals negative 9, y is positive. For what values of x is f of x equal to 0? So this is the opposite now. They have f of x, so we have y equals 0, and they want to know what is the x values. We can have more than one x value on this, so we're looking for y is 0. Y is 0 there, y is 0 there, and y is 0 there. So our x values there, we have negative 18, negative 3, and 12. So f of x equals 0 means y equals 0. What is our x values? It helps right here too because it has x equals. Just know that you can have more than one answer on that one. When they're giving you y, you can have more than one x. And positive 12. Okay. For what values of x is f of x greater than 0? So y is greater than 0 when x is, okay, so we're looking right here, and it's not an equal to, so it's going to be this section right here, and then this section right here. The kicker on this one is we have to use, compound inequality. Perfect. So since it's x values, we're gonna have, x is between these two right here. So negative 18 is less than x, which is less than our other values, negative 3. We don't have to say the top, we're saying from negative 18 to negative 3, it is all greater than 0. So here, we also have, use a comma to separate. X is greater than, or, no, not equal to. Greater than 12. Okay. I'm lying on that one. If this graph kept going, like forever, it would be x is greater than 12. Since it has this endpoint right there, it's gonna be another one of these. We're gonna have 12 is less than x, but right here we equal 18, and it's above it. So these are our two inequalities. I feel like I need to say something more about it because I feel like that was a little confusing. So we're looking at where it's over the x-axis. So where is y positive over the x-axis? And we have negative 18 to negative 3. They just have greater than 0. They don't have equal to 0, so we don't put our equal to here. So this section right here is our negative 18 to negative 3, comma. This part right here, I wrote just x is greater than 12, but our graph ends right here. If I write x is greater than 12, it goes on forever. So I had to change it because this section is just from 12 to 18. And we're only looking at our x values right here because that's all they care about. They told us y is greater than 0, we're finding x. So 12, it cannot be equal to because we're not equaling 0. 18, though, is an endpoint on the graph, so we are equal to it. I hope that makes sense. Alright, negative 18 is less than x, which is less than negative 3, comma, because we're separated with comma. 12 is less than x, which is less than or equal to 18. Key. What is the domain of f? So we're looking at compound inequality. Be sure you pay attention to how they want you to write it. At first I was going to do this last one as interval notation, and then I saw it. So domain is x, x values for domain. Our lowest x value is negative 21, our highest x value is 18. It's equal to both of them, so x is negative 21 is less than or equal to x, which is less than or equal to 18. And we use the equal to because those points are filled in, like they're all, it's a point on the graph, it can equal that point. We're on part G. I think we're halfway. Range. So range, we're looking at our y values. Our lowest y value is negative 2 here. And our highest y value is that 3. I was going to say 2, but 3 is higher than 2. And they also want a compound inequality. On this one, though, I usually make this mistake. You have to put y here. I always put x in my inequalities, but you have to put y because we're talking about range. And range is our y values. So our lowest, negative 2, y, highest. And you always use less than or equal to signs. If you were to use a greater than, you'd have to flip it all. Like you'd have 3, negative 2 is less than or equal to y, which is less than or equal to 3. Okay. What are the x-intercepts? Type an integer or a simplified fraction. So x-intercepts. It crosses the x-axis here, here, and here. We found these numbers for something else earlier. So we have negative 18, negative 3, and 12. And I bet the next question is gonna be y-intercepts. Our y-intercept is, so this is x-intercepts. And -1 is our y-intercept. You're only gonna have one y-intercept. Because if you had more than one, you don't have a function. So -18, comma, -3, comma, 12. And they just say integer, it doesn't say ordered pairs, so that's why we didn't use parentheses. Our y-intercept right there is -1. How often does the line y equals 1 intersect the graph? Okay, so y equals 1 is going to be a line where y is 1. So y is 1 right here, right? This line right here, it's close, it's not all the way there, is where y equals 1. So it crosses the graph here, here, and here of the function. So it crosses 3 times. I think we're just doing a vertical line test compared to a horizontal one. If this was a 1-to-1 function, it would only cross once. How often does the line x equals 1 intersect the graph? So when x equals 1, they go by 3's here, so it's going to be somewhere in here-ish. Oh, that's rough too. But it's only going to cross one time, because for it to be a function, it can only cross one time. Click. Still didn't click. Why did I sit down? For what values of x does f of x equal -2? So this is the opposite of what it gave us prior, because earlier they were giving us the x value and asking for the y. And it helps on this because it says x equals, so they're saying y equals -2. What does x equal? Just know when you have a y equals, you can have multiple x's. So -2. We have a -2 here and here. So -21 and 6. We're almost to the last problem now. -21, comma, 6. For what values of x does f of x equal 3? So this is y equals 3, x equals, so this one. And that's the only time, so x equals -9. And we have done problem 1. I forgot the negative. Go away. I need a negative there. I have negative wrote on this. I think I was just excited to move past this problem. Okay. Determine whether the graph is that of a function by using the vertical line test. It's not. In either case, use the graph to find the following: the domain and range, the intercepts if any symmetry with respect to the x-axis, y-axis, or the origin. Okay, I just want to add some notes. So function, no repeated x, and then domain, I don't know where to write it because I don't know what it's going to look like on the next problem. Domain is x, range is y. Okay, if we pull this graph up more. Oh, pop this graph up. Come here. If I draw a vertical line, I'm going to cross this graph more than once because these are connected. That's their graph. This is not a function because we have repeated x values, so not a function. Yes, the graph is function. No, the graph is not a function because the vertical line x equals 0 intersects the graph at 2 points. If it only intersects it at 1 point, it is a function. This one's not because it has to cross more than once. So 2 of these are just a lie and the rest is not. Our domain on this, I'll write it right here. Our domain, since it comes off the graph, it doesn't show that this graph stops anywhere. It's gonna go from negative infinity to infinity. The next question is gonna be about range, so let's go ahead and talk about that. So domain, I always go from the left to the right. So from the left, I catch that graph. At the right, it goes off of it. It doesn't show me that it stops, so I assume it's still going. Range, you go bottom to top, because when we do interval notation, you always write it least to greatest. So from the bottom, this graph is good until it gets here. And then we don't have any values right here, but then we have that value here, and then it keeps going. So our range, let me make sure that I want these in interval notation. Yep, okay. So our range is gonna go from negative infinity to this value. Now, what are they going by right here? That looks like 2, 4, 6. So this is gonna go to negative 4, and it can be equal to it there because that point is on that line. Unioned with, I don't have room to write it there, but it's gonna be bracket positive 4 to infinity. Okay. Let's go ahead and get our domain in here first. Negative infinity to infinity for our x values. And then range is next, I believe. So our range is that negative infinity to negative 4 with a bracket because it is on that line, it is equal to it at that point. Unioned with, then our graph doesn't have anything going on until we get back to 4, but it can be equal to it, so you need a bracket, and you're going to positive infinity. And infinities get parentheses. Intercepts, here we go. Our intercepts are these 2 points where it crosses the axis. It doesn't cross this x-axis, it only crosses the y-axis, but it crosses the y-axis at 0, negative 4, because I think we're typing ordered pairs, yes, and at 0, 4. So our intercepts are at 0, negative 4, because x is 0, y is negative 4. Make sure you put your comma between them. And at 0, positive 4. All the parentheses, all the commas. Select all that apply. Okay, symmetry on this graph. If I was to fold this graph along the x-axis and line it up with the top, it would be symmetric with the x-axis. They would perfectly line up. If I was to fold this across the y-axis, so from this side to this side, it would still line up. So we are symmetric with the y-axis. If I took this graph and I rotated it 180 degrees, it's going to line up with that. So this graph is x, y, origin. Okay. We're going to do that a lot, looks like. Determine whether the graph is that of a function. If I draw my vertical line, I'm only going to cross this graph once. This is a function. So yes, the graph is a function because every vertical line intersects the graph in at most 1 point. The intercepts, first domain and range. So x values, this is the x-axis. It's going to go from negative pi to pi. Since that is a value that I can look at, it has a closed dot there. It's negative pi to pi with brackets, and then our range is going to be our y values. So bottom to top, we're going to have negative 1 to 1. And this is domain, and this one is range. Our intercepts right here we have there's 3 intercepts. Negative pi, 0, and remember, for it to be an intercept, you have to have a 0 in there. It crosses right here at the origin too, and then we have pi 0. And then they're gonna ask about symmetry, but we'll get all that typed in first. Domain, bracket negative, I need a pi, 2 pi, bracket. Range is gonna be bracket negative 1 to 1, bracket. Then our intercepts, ordered pairs, so parenthesis, negative pi to 0, because if there's not a 0 in your ordered pair, it is not an intercept, pi comma 0. So we have negative pi 0, comma, parentheses 0, comma 0, parentheses, comma, parentheses, pi. All the parentheses, all the commas. Symmetry. So looking at symmetry on this graph, if I was to fold this across the x-axis, if I was to take this whole half down here and flip it up, it's not gonna line up with each other because there's nothing here, so it is not symmetric with the x-axis. Y-axis, if I was to take this side and fold it over, it would close this looking thing, but it's not going to line up with the graph, so it is not symmetric with the y-axis. Origin, if I took this one square and rotated it, it is going to line up with this side, so this one is only symmetrical with respect to the origin. And again, I'll leave that. Determine whether the graph is a function. It crosses it more than once, it is not a function, not a function. No, the graph is not a function because the vertical line intersects the graph at 2 points or 1 point. 2 points. That is the definition of it not being a function. Okay, I think, oh, we're still doing domain. So our domain, our x values, there's no x values over here on this graph. It starts at 0. It doesn't tell me that it stops, our graph ends, so that means it's gonna go to positive infinity. This is our domain. Our range, it doesn't show where it starts down here. It doesn't say that it started right here. So we assume it's negative infinity. And then from the top, it just goes off our graph, so we don't know that this graph ends. So it goes to positive infinity. And that's our range. So our domain is 0 to infinity in a bracket with 0 because the graph is there at 0. Infinity, parenthesis, check. And then our range is negative infinity to infinity because it doesn't show me that the graph ends and I don't assume. Intercepts, this graph only crosses the axes at 0, 0, so our only intercept is 0, 0. And then we have symmetry, so the intercepts is our if I was to flip the bottom half of our graph to the top, it is going to line up, so that is the x-axis. If I was to take this half and flip it over here, there's nothing to line up with it, so no y. Origin, if I took one of my quarters and rotated it 180, so turn, turn, there's nothing over there, so it's not with the origin. It is only symmetric with the x-axis. And again, this one has this open dot. This open dot is where we would use a parenthesis instead of a bracket for interval notation. So is this graph a function? It's getting closer and closer and closer, but it's never going to touch it. So like if I drew a vertical line, this is a function. So yes, the graph is a function because every vertical line intersects at most one point. The other option is in more than one point. If it's more than one point, that's not a function. Domain. So our domain values here. Oh, this is that tricky one. So our domain, it's never going to cross 0, so it's going to be parenthesis 0 to positive 5. But since positive 5, that dot is that open dot. Pay attention to that on this. It gets a parenthesis, not a bracket. Then our range, it has an arrow, so we assume it's just going to keep going all the way down to negative infinity. And then it's going to stop right here at positive 5. Once again, that dot is open, not closed, so it's a parenthesis. And then our intercepts, it crosses right here. These are going by 1, so it's going to be at 1, 0. Oh. And this graph has no symmetry. It don't matter how you fold it in, line it up. That sounded hidden. Sorry. Range, negative infinity to 5. It's not equal to it, leave it open. Intercept, they wanted ordered pairs, so 1, 0. And then no symmetry because it's not gonna line up regardless of how we fold that. Okay, question 6, 5 parts. Determine whether the graph is a function. If I had this graph and I draw a vertical line anywhere, it is going to be a function. So yes, the graph is a function because at more than 1, at most 1. Okay. Domain and range, then intercepts. Okay. Domain and range. So our x values, it has an arrow when we get here, so since it's an arrow, we assume negative infinity. All right, domain, or abbreviate domain. And then as we come across left to right, it comes off with an arrow, so we assume it's going to positive infinity. It doesn't tell us otherwise, so that's what we're doing. Range, bottom to top, so from the bottom, we have those arrows, so negative infinity. And then as it goes up, our graph stops here on our y values. So at the top of it, the highest value, remember y second, is going to be 4. It equals it there. It gets a bracket. And then we have our intercepts. Our intercepts we cross here, here, and here, because we're looking at where we cross the axis. Okay, this is a 10 though. There's not 10 tally marks. I think we're going by 2. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. That one's 4, so 2, 4, 6, 8. Okay. This one's going to be at negative 4, 0. All the commas, all the parentheses. This one's going to be at x is 0, y is 4. This one is x is 4, y is 0. Looking at symmetry on this one, if I folded this, took this bottom half and flipped it up, it's not going to line out, so no x. If I took this half and folded it across, we would have y, so let's just keep putting them in order. Symmetry, ooh, that's rough. We have y-axis. If I took this quarter and rotated it, and then rotated it again, would it line up? No, so it's just symmetric with the y-axis. Okay, let's get this typed in. Domain, negative infinity to infinity, because we had our arrows. It didn't tell me it ended, so it keeps going. Negative infinity to positive infinity. range, it has the arrows at the bottom, so we come from sorry, I just checked and saw that it ended. All I did though was this graph, we checked to see if it was a function. Anywhere I draw a vertical line on this graph, it's only gonna cross it at most one time. Now then, domain is where I was at. So domain of this graph, our first time we encounter this graph going left to right, because domain is x, we have an arrow, so that's gonna be negative infinity. And then as we come across this graph, the last part of the graph we have is also an arrow, so it's gonna keep going to positive infinity. Then our range, our y values coming from the bottom to the top. The bottom of the graph, the first time we get to this graph, we have that y value -1 there. And it is a dot, so we're equal to it. So we use a bracket. So we're going from -1, and then as we go along this graph all the way to the top, the last thing we see is that arrow. So since it's an arrow, it's gonna go to positive infinity. Then we need our intercepts. So they cross right here, here, and here, because you just look for where it crosses an x or y axis, because you have to have a 0. So our x right here, our intercept, is gonna be -4, 0. And then it's gonna cross at -2, 0. And then we're crossing at, what are they going by right here? Because that's 6 to 12. So 6, 8, 10, 12. So this is 8. Be sure you're checking your scale. X is 0 here, y is 8. And then while I have it pulled up, let's look at symmetry. Since this graph is not lined up, like with an axis, it's not like I can say the x over here, when I fold it, it's gonna line up. There's no symmetry with the x-axis. If I was to take the bottom and fold it across the top, it's not gonna line up because it's not centered with our origin here. And then along the origin, it's not lined up with the origin to be able to rotate it, so there's no symmetry on this graph. But let's get this started. So our domain, we had those arrows, so -infinity to infinity. Our range, it started at that point, and that point actually even had a dot on it, so bracket -1. If it didn't have a dot, we would still use a bracket because it is at that point. So bracket -1 to positive infinity. Always put parentheses with infinities. And then our intercepts, be sure you watch your scale. -4, 0, comma, -2, 0, and then it was 0, 8. Parentheses and commas. And then since this graph wasn't lined up, this has no symmetry. They could ask if you have symmetry with the line x equals, and that's gonna make it a different kind of problem. But you could have like symmetry along the line x equals 3 would have put it in the middle. We need to get rid of this too. Answer the questions about the following function. F of x equals 2x squared, subtract x, subtract 1. Is the point -2,9 on the graph of f? So, I accidentally clicked one over there, but I have not checked it. Remember this, f of x equals y, so I'm gonna have 9 equals 2, and then instead of x, we're plugging in this -2 squared, subtract, instead of x, put in that -2. And if this simplifies out to 9, it is on the graph. If it does not, it is not on the graph. So 9 equals -2 squared is +4. I'll just go ahead. I have to. Negative and a negative would be +2 minus 1. 9 equals 2 times 4 is 8. 2 minus 1 is 1. Is 8 plus 1, 9? 9 equals 9. So yes, because f of -2 equals, that's pretty cool. If x equals 2, what is f of x? What point is on the graph of f? So x is 2. So we're finding out what f of x is. And x is 2. So we're going to do 2 squared, subtract 2 minus 1. We put 2 in for x, so 2 times 4, negative 2, and negative 1 would be subtract 3. So f of x equals 8, subtract 3. F of x equals 5. That's roughly 5. And then they want to know the point on that graph. So using the information in the previous step, this is x, this is y. List the point, type in ordered pair. So our x is 2 and our y is 5. That's what they want right here. Okay, if f of x equals negative 1, what is x? So they gave us y, and they want to know what x is. This one will be probably a little more mathy. Oh, so negative 1 equals 2x squared, subtract x, subtract 1. Since this is going to be a quadratic equation because we have an x squared, I'm going to add this one over here. Negative 1 plus 1 is 0. Negative 1 plus 1 is 0. So if 0 equals 2x squared, subtract x. Now that I have it like this, I'm going to factor an x out to the front. So I'm going to have x times 2x subtract 1. So it's no longer x squared. Are you sure you want to leave? No. And then we set both of these equal to 0. So I'm going to have x equals 0. And then we have 2x minus 1 equals 0, and we have to solve this one. So 2x equals 1 divided by 2. So x equals 0 and x equals 1/2. And separate answers with a comma as needed. Okay, and then they're going to run us to use points again. Remember, this is our y value, and these two are our x values. So we're going to have 0, negative 1, and 1/2. Okay. 1/2, negative 1. Because these are our x values, and our y value is this. This is y. Type that in. So they want us to find it, and then they want to be sure that you know which one's x and which one's y. That's because this part is just, we're repeating what we just found, but we're putting it as an ordered pair. So you have to know which one's x and which one's y. B. What is the domain of f? So our domain, since this is a quadratic equation, it's negative infinity to infinity. Why do I know that? How do I explain that? I can show you all the graph of it to explain it. There's nothing that's going to make this undefined or not real. There's no fraction, there's not a square root. That is why our domain is negative infinity to infinity. List the x-intercepts, if any, of the graph of f. Select the correct choice, and if necessary, fill in the box to complete your choice. So x-intercepts is when y is 0. We'll go ahead and find the y ones too while we're at it, because this is going to be When I have 2x and this one here, there's different ways to factor. If you factor a different way, that's okay. I don't have time to go into all the details of factoring. I have a plan to make a supplemental video of it, but we did some factoring in chapter 1. So when I factor this, I'm gonna split it as 2x and x. Then I have my numbers 1 and 1, so they're both 1. I need a -1, so I'm gonna put a negative here and a positive here, set it equal to 0. And then I solve both of these, so I have 2x plus 1 equals 0, and x minus 1 equals 0. So x equals -1/2, and then this one would be add 1, and x equals 1. So I have -1/2 and 1. And that's when y is 0. They don't want it as an ordered pair. Use a comma, so -1/2, comma, 1. List the y-intercept if any of the graph. Select the correct choice. So this was our x-intercept. Y is easy. Our y-intercept, y equals 2 times 0 squared, subtract 0, subtract 1. Anything times 0 is 0, so y is going to end up equaling -1. Because all of that goes away, because that gets 0, so it ends up just being -1. Any questions on this, so I know more so what to tell y'all to help you. So if you have any questions on this, write them down and send them in an email so you can help me help people. And I can even make a new video. Answer the questions about the following function. Is the point 3 13/3 on the graph of f? So this is our x value and this is our y value. So we're wanting to know if 13/3 is what 3 plus 6 over 3 minus 4 equals. You don't touch this side, simplify this side and see if it equals this side. So 13/3 equals 3 plus 6 is 9. 3 subtract 4 is -1. No. So my x value is 3, so no, because f of 3 does not equal 13/3. If x equals 2, what is f of x? So we're putting 2 in for x and solving it out. So then we have f of x. Remember not to put your 2 in here. I feel like that's a mistake. I see a lot. So we have 2 plus 6 over 2 subtract 4. 2 plus 6 is 8. 2 subtract 4 would be -2. 8 divided by -2 is -4. Then they're going to want us to write this as an ordered pair. They gave us the x value. They said x equals 2. So we're going to have 2, and then we found the y value. 2, -4. If f of x equals 2, what is x? So this is, they gave us y equals 2. And they want us to find x, so here we go. To get this off of the bottom of this, we're going to have to multiply by x plus 4, like all of it. And you don't really, when you multiply by it over here, it'd be something divided by itself, which is 1. And that looks ugly right here. So we're going to end up with 2x plus 8 equals x plus 6. I'm going to subtract this x. And then since I have my x's on this side, I'm going to move this 8 over here. So I'm going to end up with x equals 6 subtract 8 is -2. Oh, no. It has to just be me. Substitute the given value. Well, let me double check. Y equals 2, because f of x, what is the x value? Oh. No. Oh, 2, it's x minus 4. Watch your signs, team. So I put x plus 4 right here. So instead of a plus, it's a minus. So let's just go ahead. That'll change everything. And this is y equals 2. Okay. X minus 4, not plus 4. So I'm going to multiply both sides by x minus 4. And that would be x minus 4 divided by x minus 4, which is 1. And then we have 2x subtract 8, not plus 8. I guess my hair did that. Okay, then we're going to subtract our x like we did. But now then, instead of subtracting 8, we add 8, which changes everything. So 2x subtract x is x, and 6 plus 8 is 14. Signs. But there's your reminder on why I always check for partial credit, because one little thing. Okay, using the information in the previous step, list the points on the graph. So we found our x value, they gave us our y value. So we have 14, comma, positive 2, because that's the ordered pair. Okay. Domain, this one, since it is a rational expression, it's that fraction, we can make it undefined at a point when 0 would be on that denominator. So since it's x minus 4, what subtract 4 equals 0, because it cannot be that value. So if I added 4 over x equals 4, makes this graph undefined, so x equals 4 cannot be in the domain. And they want it in interval notation. So when we write this in interval notation, we're going to go from negative infinity to 4. Don't put a bracket, we can't equal it. Unioned with 4 to positive infinity. Because that is, there's a hole in the graph at that point. If you type that in to a graphing calculator, you would see that. And union button. Oh, I got it. Okay. 4 to infinity. List the x-intercepts. So x-intercepts is when y is 0. So 0 equals x plus 6 over x plus 4. If we're solving this, and we multiply by x plus 4. This is gone. And that's gone. That's 1, this is 0. And then it's undefined at, I did plus 4 again, but it's okay on this one, but it's subtract 4. But it's undefined at positive 4, so this is our x-intercept, and then when we do x equals 0 for our y, we'd have 0 plus 6 over 0 minus 4, and this would be 6 over negative 4. That's going to reduce because 2 goes into both of them, so we're going to have y equals 3 over negative 2. I don't know why it gets so crooked every time. It has to be me. It's my fault. Okay, so -6 is our x-intercept. Do they want it as an ordered pair or just an integer? Integer works. Oh, wait, and then our y-intercept is that -3/2. You can't really see the negative because it all went together on mine. Oh, and that's it.